Now that we have understood the constant and linear time complexity analysis, let's look at the time complexity analysis of n square units of time. By using the big O notation, we will usually represent it as order of n square, where n is nothing but the size of the input that we are getting. To understand this order of n square units of time complexity, let's look at the small sample program that I have written here. So I have written a function called multiply array values, which will basically take the array of values as a function argument. What it will do is it will try to multiply each and every value with each and every remaining values we have in the array. For that, obviously I have to run a for loop from 0 till the length of the array, and in each and every step I should move on to the next element, right? That's why I'm incrementing I by 1. Internally inside this for loop I'm writing one more for loop, which again start from 0, executes for all the values by going on to each and every next value. So ultimately inside the next for loop, I'm creating a variable called result, and I'm basically multiplying the values that are available at ith index and jth index. And in the end, I am printing the result so that I can move on to the next element. Again, the process will continue till we reach the very last value we have in the array. So here, if you see, right, let's go line by line and let's just try to understand what could be the time complexity of this execution. For example, if you see here, right, whatever the outer for loop that we have written is executing for all the values of the array by going on to each and every index. So if we assume that there are n number of elements on the array, the outer for loop is executing for n times, right? Internally, whatever the internal for loop that we have written, it is also executing for each and every value of the array. As a result, this for loop is also executing for n number of times. Internally inside the inner for loop, whatever the result variable creation and assignment that we are doing is going to take 1 unit of time, because it is a mathematical operation as well as assignment operation. And after that, whatever the printing we are doing, it is also going to take unit amount of time. So combining all this, let's just try to understand what could be the time complexity of this implementation. Now this internal inside the nested for loops, initializing the result and printing, the time complexity is 1 plus 1, which is nothing but 2. So inside the inner for loops, calculating the result and printing is going to take 2 units of time. But if you remember the rule that I have mentioned, whatever the iterative statements that we use in our implementations, that amount of time they take will be equal to the number of times they are running, right? As a result, this inner for loop will be running for n into 2 times, which is nothing but 2n. But here we also have outer for loop. As a result, outer for loop is running for n number of times, right? As a result, the overall time complexity will be 2n into n, which is nothing but 2n square. Here, according to one of the rule that we have, where we neglect the lower order terms and the constants we get inside the expression that we get, which will basically say the time complexity of the multiply array values program that we have will take n square units of time. Very simple calculation. So according to the rule that I gave, whatever the iteration statements time complexity will be equal to the number of times it is iterating. As a result, whatever the outer for loop that we have written here is executing n number of times, and the inner for loop is also executing n number of times, and internally whatever the printing and result calculation is going to take constant amount of time. As a result, after multiplying all these values and adding the internal printing and result calculation, the amount of time that we get is 2n square. According to one of the rule, we will neglect all the constants associated to higher order terms, and we will also neglect all the lower order terms. The time complexity that we are getting will be n square. Using the big O notation, we will represent it as order of n square units of time. Okay, now let's just try to draw a graph and see how this graph will actually look like when we try to plot it. So on the x-axis, we will be taking the size of the input array, and on the y-axis, we will take the amount of time taken. Now let's just try to see what are the possible values. So here n is the size of the array and the time complexity, let's just take. If at all, if the array has a size of 0, right, 0 square will be 0 only. So array size is 0 and the time taken for that it will also be 0. For example, let's just say array has only one value. In that case, 1 square will be 1. So when n is 1, the time is 1 only. When we have an array of size 2, the n square value will be 4. Similarly, when we have array of size 3 square, it will be 9. So if we try to plot these values into the graph, right, let's just say on the x-axis we have 0, 1, 2, 3, 4, 5, and on the y-axis let's have 2, 4, 6, 8, 10, 12, 14, 16. Now when we have n0, the time complexity is also 0. When we have array of size 1, the time complexity is 1. So somewhere it will lie somewhere here. When we have array of size 2, what is the time complexity? It is going to take 4 units of time. Similarly, when we have array of size 3, it will take 9 units of time. Similarly, if we have array of size 4, if at all if we had, n square will be 16. So at 4, we will have 16. So if we try to draw a graph of all these values, right, the time complexity will look something like this. Okay, so all we had done is we assumed some values of the size of the array and we have deployed those values into this n square expression and we plotted those values on the graph. So obviously by looking at the graph we can say the best case time complexity is constant and the worst case time complexity will be order of n square based on the size of the array that we are getting. Okay, so that is one of the examples of getting the n square units of time and trying to plot it on a graph. So the most important thing that you have to take away from this example is based on the number of nested for loops that you are writing, the time complexity will also increase according to that. For example, let's just say we had 3 for loops nested in each other. Now each and every for loop is also running for n number of times. As a result, the overall time complexity of this will be n cube. If at all if we had 4 for loop, then the time complexity will be n to the power of 4. Okay, so that is something that you should take away from this example. Okay, now that we have completed this, let's just go ahead and let's just try to understand when we will get the log n based time complexity.